Hey guys, Paul Danner here, also known as ScannerDanner on this channel. Today we're doing a no crank diagnosis on a 2009 Chevy Silverado. That is my truck. It died on my son in the driveway, and we're gonna be doing some starting system testing. So as with any no crank diagnosis, there are so many different directions you can take and so many different test methods that can be used. And I'm gonna do my best to show you many different ones, starting with the most basic. Old school, get yourself an old school incandescent style test light. We're gonna go directly to the starter and do checks there first, because this can be applied to every car that's on the road. If you reach out to me, you're looking for help for your no crank problem, I'm gonna have you go to the starter and do these 3 checks first. Okay, I lied. Before we do the 3 checks at the starter, there's 2 more things you're gonna need. 1, you're gonna need a partner that can crank the engine over for you. And 2, we wanna make sure that our battery is good and that our no crank issue is not from a dead battery. Turning my key on, trying to crank it. Oh, I heard a click that time. 1 click, that's a good guide too, but that can also be a dead battery. There's something else that can be done. Turn your dome light on. Watch your dome light as you crank it. Cranking now. Notice the dome light never dimmed. If you have a bad battery and it's dead to where you're not getting any sound at all, that light's gonna dim pretty badly on you. So that's a clue. Not a perfect test, but it's a clue, okay? Battery voltage check, and then we'll go underneath. My apologies for the poor lighting. The sunlight's really messing up this shot, but negative lead to battery negative, positive lead to battery positive. All right, you can see we're reading 11.9 volts. Go ahead and crank that, Bo. Okay, let go. So 1189, hold it in the crank position. Down to 1181, so there is some current flow there. Okay, that's good. What that tells us, guys, this is not a battery issue. Going down to the starter now. All right, I think what we'll do is add the voltmeter checks at the same time as the test light, so we can kind of shorten this video a little bit. One of the things that I'm using is a very long extension cable for my ground. I like to go to the battery when possible, and because of a friend of mine who sent this to me a long time ago, thank you very much. This can be used for battery ground or power. It's fuse protected too. But now I have known good grounds directly from the battery going underneath this rusty truck. It's important that you have a known good ground for your multimeter when you're using one. I'm using a lab scope, we're just using the multimeter feature for it, and now I know my ground is good. I have other videos talking about how to check for that. We won't focus too much on that for here, but you have to have a known good ground when you're doing measurements. Okay, for my test light, I'm going to my transmission housing because it's a clean area for my ground. And then I really need to check that ground first before I do anything else. And that's gonna be as simple as touching this positive terminal, which is hot all the time. Making sure my lights. Okay, test light's lit, tells me my ground is good. Also tells me this battery post is hot all the time like it should be, but that's not a good enough test. You have to have current flow. You must crank the engine over. Go ahead, crank it, Bo. Crank it. Yep. Let me know when you are. No change in the light as he's cranking it. Go ahead and let go. Our problem is not in this heavy battery cable or the eyelet that's on here. Here's a quick clip of one with a bad eyelet. Even though it's hot all the time, you can't say, hey, that's a good test. It's not. There's no current flow. So go ahead and crank that, Caleb.
All right, ready?
Yep.
Cranking.
Nice. Perfect example. Perfect example of a voltage drop. You hear how heavy the solenoid was, the click? That's really irrelevant for this. The fact that this light goes out when we're cranking tells us our voltage drop is occurring on the heavy gauge wire. This does not need a starter. So how important is it for this step to go to the stud? Super important, as you just saw. However, in the video you guys just saw, the starter was clicking heavily, so that's a clue. Trying to get on the stud. I'm now on the stud of the starter. Go ahead, hit the key.
Yep.
You're on it?
Yep.
All right, so our issue is not on the heavy post, the heavy terminal, the heavy cable. All is good, even though it's got some green cruddies on it, which isn't good. That is not our problem, okay? Next one's gonna be the starter solenoid wire, which is just above where I am. It's a white connector. Now this part for you guys is going to be a little tricky depending on what tools you have. I'm using a back probing tool that's part of my lab scope. You can buy yourself some T-pins at Walmart or somewhere else. It's in the sewing needle section. Those T-pins work really good for back probing. You want to back probe this because you don't want to unplug it. Unplugging it makes the load for the circuit go away. You want the load to be there. So I have my test light touching the pin now. Go ahead and crank it, Bo.
Yeah.
Holding it in the crank position, let off. Crank it again. Good, let off. Crank it again. Okay, all right, let off. So that is a loaded circuit test because I'm plugged in. I'm relying on the starter solenoid itself to draw the current, same way I did with the load side of the starter. I'm relying on the load of the starter to load this wire, not my test light. I'm using the test light as a guide, but I'm not relying on the test light load. I'm relying on the starter. This has to be plugged in. You have to be plugged in for this to be accurate. All right, one more check. It's gonna be on the housing itself. I know my test light already has a good ground. I'm on the block. I'm just touching on the housing of the starter, and I wanna make sure that this housing does not light. Now, granted, it's grounded to the block, and so chances of that having a bad block ground are slim to none because we'd have other symptoms, but this is how you check it. Go ahead, crank it, Bo. Light doesn't light, nothing wrong with the ground. Those are the 3 checks you need to do, and I'll show you what a bad ground one looks like. We'll pick one right here where I'm actually touching the block, and you see the test light's lighting. That's what a bad block ground looks like. All right, so the 3 checks at the starter, just to review: the heavy post, right? Make sure you're on the post itself. The solenoid wire, make sure it's plugged in, and then the housing. So that's it for the test light. If that's all you had, that's enough. Change the starter, you're done. All right, same checks using a voltmeter, starting on the solenoid wire because that's where I left off with the test light. Go ahead and crank that for me, Bo.
Yep.
So we're at 11.3 volts. Let off. No problem at all. If you got 9+ volts on that wire, that's enough for that solenoid to do something, to click, make a noise, right? Do something. Again, you must make sure this is plugged in. Do not unplug this circuit and measure voltage because there will not be a load on it. It will be inaccurate. It has to be plugged in, okay? Solenoid circuit, nothing wrong with it. We got near battery voltage on that. Next one, go into the stud. Again, why do we go to the stud? I showed you guys what a bad eyelet to stud contact looks like. I'm going to the stud of the heavy post. Tough for you guys to see. I apologize for that. Okay, 11.8. Go ahead, crank it.
Yep.
You're holding it in the crank.
Yep.
Went to 11.7. Our issue is not with the heavy post. Again, it's hot all the time, so you may not feel the need to crank it over because it's already hot. You have to crank it. You have to crank it, okay? And then last one is gonna be your block ground, which is just gonna simply be on the housing itself. And my meter, in this case, is going right to the battery as I showed you earlier. So just touching the housing with my pin. Try to make good contact here. Okay, crank it. No voltage on that ground, totally fine. Ground to ground voltage drop test. All right, needs a starter with the voltmeter too. Okay, let me show you some more checks we can do up here at the fuse box. My starter relay is right here. Using my diagram here, I've located that. You see it's that guy right there, it says starter. So it's this guy. And one of the things you can do, now we already know this needs a starter, but rather than climbing underneath first, you want to make sure that you have ignition switch control, meaning that when we crank it, we're getting power to this relay. The relay is actually powering up. If it's not, if the relay is not powering up, then there's no reason to crawl underneath, right? Then we focus inside on anti-theft systems or park neutral switch problems or ignition switch problems, things like that. So I like to do relay checks first. We're doing this backwards from normal, but quick checks on this. Any relay, you need a load side power and a control side power. The load side's the switch contact that's going to go down to the solenoid, and then the control side would be the coil of wire that makes a magnetic field to make the switch closed. And so we're just going to check all 4 pins using my test light, making sure it lights. It does not. Bad ground on my light. Okay. Then the end of this test light is too fat. So yeah, you don't want to stuff this in. These are not reaching those pins. So what I'm using is that same adapter I was showing you earlier. This will be thinner. I can go to each of the pins now. Go ahead and crank this for me, Bo. I'm looking for 2. Actually, I should have one that's hot all the time. There it is. There's one of them. So that's bottom right, and then none of the other ones are lit. And then go ahead and crank it. Let off. Crank it. Let off. There's my other power feed. So we are getting power to the relay. And the other thing too, it's kind of tough to tell with relays clicking because we have other relays that are clicking in here too. But if you hit the key, go ahead. Get my mic on it. Let's see, hold on. Put my mic on that so you guys can hear it. So you can do a sound test too. Go ahead, crank it. Let off. Crank it. Let off. Now that can be misleading because you have a few relays that are clicking in here, but that's sufficient, at least initially. The other thing that you can do sometimes is lift the relay up, and you can do checks now with your test light. If you don't have a pin like this, with the relay lifted, you can get your relay in there. You got to be careful with this though. If you cross 2 pins, you can literally smoke the engine computer driver for the starter with this kind of testing. So you got to be careful. But there's my hot all the time. And then the top left one up here was the one that was hot when he cranked it. Go ahead, crank it again. All right. And then this one should be load side down to the starter. Go ahead, crank it. Nope, let off. Then it should be this one up here then. Go ahead, crank it. I'm not making contact. I really need to be careful what I'm doing. I don't really like this method that much. I'm not really able to touch that pin very easily, and I don't want to cross them. Okay, so you see the limitations of that. You can take a piece of wire, take a piece of copper wire and wrap it around there and plug it in, but you can't let it touch anything else. So they make tools for us in the field that make this kind of testing so easy. I really like my stand here, garbage can, but this is from my friends at AES Wave. This is called a U-Activate. Probably one of my favorite tools that I've ever purchased. It's a relay circuit testing tool, and there's all different adapters for different relays in here. These are just some of the different relays, okay? Mine's the orange one. So we just plug this guy in using the 4-pin design. Plug this into where the relay goes, and this will be our different pins on the relay itself. 85 and 86 is my control. You see the little coil of wire. Then we have our load side, 30 and 87, normally open contacts. We're not dealing with the 87A, the normally closed contact on the relay on this, just these 2. But first thing is, watch the LED light here when I crank it. That light should light. That's our control side power that I showed you is there already with the test light on the relay. But watch the LED, it's gonna light. Cranking, off, cranking, off. So what's that tell you about your ignition switch, anti-theft, park neutral, all of that, engine computer driver? It's good. It's turning this control side, has a power, has a ground, that's why the light's lighting. The second thing you can do with this tool is you can be the relay itself. If I flip this switch right now, it should crank. It's not cranking, which we know already our starter is bad, but that bypasses and just closes the contacts directly on the circuit. And you can check the circuit. That's what all these ports are for. I love that too. Like let's say your LED didn't light on the control, you can come over and do circuit testing on that. Let's get stuff out of the way so you guys can see. But like, you can put your test light on here, test light here, make sure we got a good ground. Test light here on 30, right? That's lit on 30. And then it's not lit on 87, so there's ports up top, okay? Not lit on 87. It is lit on 30, but watch 87 when I flip the switch. Okay? That should be cranking the engine over. It's not. So the fact that when I plug this tool in, I still can't crank the engine over also tells you the relay was never the problem. If you had a relay problem, as soon as you plug this tool in and flip the switch, it would crank the engine over. Now, as far as relay problem goes, it could be the relay itself or other issues. You'd go further depending on what you have. Like saying let's say 86, weird that LED light is going out with my test light in there. Don't worry about that. That's just how the tool is wired, and we're getting some feedback with that LED. But watch my test light when I crank it. This would be like if the LED didn't light, for example. Right, you see my test light lights on that side when I hit the key and I'm cranking it. And then you check your ground side. You just switch your test light. That'd be this one. If that's power, this has to be ground. So I switch my test light to power, just on the fuse box itself, and then touch on the green wire. And this should be on the green pin. This should be lit all the time. Just knowing circuit design, right? It's lit all the time. So you dissect your control side, and then you can go further on the load side too, which is, we'll stay now on battery power. So when I find a ground, my light's gonna light, touching the fender there. And if you know anything about starter circuits, when it's deactivated, when the starter's not energized, which it's not right now, my switch is in a neutral position. If I touch on pin 87, this test light should find a ground, and it is, through the solenoid circuit itself. So if my test light is lit right now, I don't have, key doesn't need to be on or anything. This is just unenergized on the solenoid circuit, test light connected to battery power. It is finding a ground through the low resistance solenoid circuit, which means the wire going from here all the way down to the starter, into the solenoid post, through the solenoid windings. There's two of them, a pull-in and a hold-in winding. Going to ground through that circuit is my light. That's why my light is showing lit. It's finding a ground through that. If you do that check and this light's not lit, you have an open circuit. That's really sweet, isn't it? Open circuit could be the wiring going down to it, could be the eyelet itself, like the solenoid post, or it could be the starter itself. Now, variables, you would need to do further checking, but if that light lights, how is all of that? It's good. And that's the function of this LED test that they have on here. When I hit this button, it should light, and it's lighting on 87. Same thing my test light was doing up here. This is nothing more than a continuity check, okay? Yes, the LED is not gonna load it like the circuit. Neither is my incandescent, but this just substitutes the need to grab your ohm meter, and you can do that on these load circuits, right? This solenoid circuit is a load, not as high of a load as the battery post part of the starter, but it's still a load. And you can check circuits like that, fuel pump the same way. Check power on a fuel pump circuit from the relay. It should have continuity to ground when that fuel pump is not spinning, when it's de-energized. That's what that LED test does right there. A little push button, right? That's freaking sweet. Love that. And then of course, it's not cranking. Do your loaded circuit checks. If I'm by myself, when we started this, what I would do is I'd plug this tool in, I'd do some quick checks up here and making sure my control works and everything. And then the next thing I would do is flip the switch, which is now cranking all the time, right? That's basically, you're simulating you're in the crank position all the time. And my circuit's loaded. So now when I go down underneath and do my power and ground checks at the starter on both the BAT post, the S post, and then the housing, those three checks, it's loaded all the time. I don't need somebody inside the truck cranking it over for me. I can do my checks down there and be done. So I would use this tool right off the bat for that reason. Constant load, it'd be like you holding the key in the crank position. Pretty cool stuff. All right, one more piece with this. Amperage. We can check the amperage of the circuit, which can tell you a lot too. So let's get a quick amperage reading. All right, I'm just using an inductive amp clamp here. And the setting for this clamp is every 100 millivolts of output is 1 amp, okay? And so what I'm gonna do is just clip it over this and then hit the button, and we should see an amperage reading, and we do. All right, so let's talk about that for a second. All right, so minus 0.02 is that's our zero line, okay? Just using a multimeter, an inductive amp clamp, you can find these for like $100. Inductive amp clamps you need to have if you're doing troubleshooting. If you're working by yourself, you can use an in-series ammeter. It's a lot more complicated. When I'm doing troubleshooting, this tells me a lot. I use this setup a lot. Watch, flip the switch. What do we go to? 0.9. 0.9. Let's see if we can change the setting for you guys so we get a little bit easier math. So let's set this to 1 volt. And now 0.1 is going to be 1 amp, okay? 0.1 is 1 amp, so watch it. 0.8, we had 0.9 for a second. That's 9 amps of current flow. So if I were to start here and do my checks, engine's not cranking, make sure my battery's good, hook up my U-activate tool, put an inductive amp clamp on here, flip the switch, see 9 amps of current flow. Almost 9. I'm done. I'm done. I mean, it needs a starter. That test alone. Now, you should go underneath and make sure the battery posts, because this is really just the solenoid circuit, but I don't hear the solenoid clicking. So the battery post part of the starter, yeah, we're not checking that here, but I'm not hearing the starter click, and I have 9 amps of current. So what does that tell you about the ground of the solenoid housing and the solenoid itself? If you have 9 amps of current, it should be higher than 9. Initial amperage of a starter solenoid is usually about 40 initially, and then pulls back on the hold-in winding once the pull-in one collapses. But 9 amps of current tells you that you're done. You're done, it needs a starter. If this was a fuel pump and you had no fuel pressure and you did that check, you're done, you need a fuel pump. So I hope that makes sense. On the stuff that I'm showing you here, I have a lot more of this kind of stuff right here actually in this playlist. There's a lot more no crank starting circuit tests and all throughout all the case studies that we do. So let's change the starter now and see what happens. Disconnecting the battery is of utmost importance when you're doing a starter. Okay, done. Okay, does it crank is the question. Key is off, so it shouldn't start. Back to this guy. We'll just kind of flip the switch here. This should crank. Cool. All right, let's do some measurements real quick. Some after measurements. I might switch back to the lab scope for this so we can catch this, because we got pull in and hold in windings now going on. I'm not sure we'll see. Yeah, it's just such a fast signal. Let's reset this amp clamp. Oh, there's your 7 amps of current it was showing there. Let's see if we can get a min-max here for you guys. Let's go 5 volts. And flip the switch. Yeah, there was 22 amps, 2.2 at the max. That's 22 amps initially, but then your average, your hold time, watch it. 7 amps of current. Hope you guys learned something from this. This is basic starter 101 troubleshooting. In fact, this applies to so many other computer controlled relay circuits the steps that I just showed you guys really apply across the board. So let's hear the engine run now. Take this out. And I'm gonna just say one more thing and a little bit of a rant here, because when I do these shorts and reels that I do, which are about a minute long, and I show starter checks using a simple incandescent style test light, and you get hundreds and hundreds and hundreds of people that tell me I'm a fool and I don't know what I'm doing and this isn't a voltage drop. Yeah, I know I don't want to speak to the naysayers. I don't care about that. But what I do care about is when other people come in and they read that, it sways them into trusting me or not. And what I want to say is the checks that I just showed with just the test light was enough to condemn this starter. It was an accurate call. And again, these clips that I shared within this is where you'll find some of those other ridiculous comments, in particular the one where the test light goes out from that bad eyelet on my son's Jeep. Crazy stuff, man. Crazy stuff. Okay, relay back in. This is gonna start and run now. Exhaust leaks. A true mechanic's car. Thanks for joining me, guys. I'll see you next time.